In the third video on trig functions and identity, we start with a proof of tan a minus b. There's multiple ways to do this. Tan is equal to sine over cos. So the tan of a minus b will be equal to the sine of a minus b over the cos of a minus b, which we have values for in the tables. The sine of a minus b is sine a cos b. Minus cos a sine b, and the cos of a minus b is cos a cos b plus sine a sine b. Now that's really all you need to know in this question, because if we focus now on this number 1 here in the question, how do I get a 1 in that position in the fraction? I'm going to have to divide everything by cos a cos b, or divide cos a cos b by cos a cos b, so therefore divide everything. So we can do that off to the side here. Sine a cos b divided by cos a cos b. You should see what happens here. This position here is going to become sine a over cos a, which we know is tan a. Then we have minus, I'm dividing cos a sine b, this guy, by cos a cos b, and then we have sine over cos. You can see what's cancelling, so that's going to be sine b over cos b, and that's all divided by this guy will become 1, and then plus sine a sine b divided by cos a cos b is going to be tan a tan b. So actually I might simplify that now. It's just tan a tan b. Therefore the whole thing is going to become tan a minus tan b all over 1 plus tan a tan b. There are some quicker ways to do it, but I think that's my favorite way of doing it. It helps kids remember when that 1 is there, how do I get it? This is a question we've seen in one of the other revision videos, these special angles of 60, 30 and 45. How do I get 15 with these numbers? Well, that's going to be the tan of 60 minus 45. So the tan of 60 is equal to root 3, and the tan of 45 is equal to 1. And it's based on the previous question, so the answer for tan a minus b, which we have here, is going to be tan a minus tan b. So that's going to be root 3 minus 1 on top, and on the bottom you could write it in long form, tan 60 minus tan 45 over 1 plus tan 60 times tan 45. So we get root 3 minus 1 on top, and on the bottom we get 1 plus root 3 times 1, which is going to be root 3 minus 1 over 1 plus root 3. The answer to this part. This question, it's the unit circle again. When is tan negative? C-A-S-T. So we want to use these two sections here where cos and sine are positive, and the inverse tan, we had it in the previous question, of root 3 is 60 degrees. So we draw our 60-degree angle, which in this sector will be 300. And we draw our 60-degree angle in here, which will be 60 less than 180, 120. Adding 360 on, we get 480 and 660. And if we add on a number again, we're going to get a number greater than 720. So the answers here, A will be equal to 120, 300, 480, and 660. This has to be the most confusing question I think that's ever been asked, just with the amount of words in it. But basically we have an increase in a tree's radius year on year given by this function, and we're told that the initial radius is 10 centimeters at some part within this question. So a lot of information here, but the maths involved is a little bit tricky at parts. So in order to model, for the model to be reasonable, it must satisfy a number of conditions. The radius of the trees is increasing year on year. Well, we know here that the max value of this function, and this is based I of t, the increase in t is going to be 1.5 plus 1. So the max radius increase will be 2.5 centimeters, and the minimum value of this function is 1.5 minus 1, which is 0.5. So the radius always increasing, and you've shown the max of 2.5 a year and a min of 0.5 a year. Then we're asked to just sub in two values here. I of 6, is it less than I of 5? Well, I of 6 is going to be equal to 1.5 plus the sine of 6 pi over 5, and I of 5 will be equal to 1.5 plus the sine of 5 pi over 5, which is just pi, and the sine of 180 is 0, so this is just equal to 1.5. So that's in year 5. Year 6, I'm getting 1.5 minus 0.59, which is equal to 91 or 0.91, 91.91 of a centimeter. So I6 is less than I5, yeah. And what does that mean in the context of a growth of a tree? Well, the radius has less growth that year than the year before, something along those lines. Then we have two identical trees growing in a forest. At the beginning of year 1, a tree was cut down and a section of the trunk in the shape of a cylinder of radius 10 and standard length h and volume v1 was sent to a sawmill. Given that R0 is equal to 10, that was given in the initial part of the question, RT plus 1 is equal to RT plus the increase in the year after. Find R2. Well, R1 we need to find first here. I think this would have tricked a lot of people. R1, if we follow this formula, R1 will be equal to R0 plus the increase in year 1, and R2 will be equal to R1, the radius after year 1, plus the increase in year 2, and R1 is this expression above here. So R2 becomes R0 plus the increase in year 1 plus the increase in year 2, and we're asked to show that it's in this format here. So R0 is equal to 10, the increase in year 1, we had from up above we had 1.5 plus the sine of pi t over 5, which is the same expression here. So the increase in year 1 is 1.5 plus the sine, if t is 1, just pi over 5, and the increase in year 2 is 1.5 plus the sine of 2 pi over 5, and this is the format they wanted it in, given here. At time is equal to 10, a second tree was cut down and a section of a trunk in the shape of a cylinder and standard H and volume V2 was also sent to a sawmill. If the second volume is K, a constant times the first volume, where K is an element of R, find K. Okay, so we're going to have to find R10 here. It wasn't as obvious maybe at the start as to what was going to happen here. But R10 is going to be equal to, based on this formula here, it's going to be equal to the radius at the beginning plus the increase in year 1 plus the increase in year 2 all the way to the increase in year 10. So it seems like there's a lot of work involved here. You might see a pattern quicker than me, but that's going to be 10. The increase in year 1 is 1.5 plus the sine of just pi over 5. The increase in year 2 is 1.5 plus the sine of 2 pi over 5, and it's all going to go all the way to year 10, which will be 1.5 plus the sine of 10 pi over 5. So we have a sequence here. Now what's going to happen here is all these angles, we're going to have 10 at the beginning, and we're going to have 1.5 10 times, and we're going to have the sine of all these angles. Sine of pi over 5 plus the sine of 2 pi over 5, So what I'd suggest is pause the video now and find out what the sign of all these angles are and see how quickly you can see a pattern emerging. And it wasn't until I got to the sign of 6 pi over 5 that I saw that the pattern was going to cancel out all the values of the angles. So what we end up with is just the radius after year 10 is going to be 25 centimeters. So the volume of these cylinders, the volume of the first one is equal to 10 pi r squared h, and we'd have to multiply, sorry, pi, the radius is 10, so k, I meant to put it at the beginning, k times v1, and r is 10, so we have k by 10 by 100 by h, and volume 2, the radius is 25, and it's just volume 2 on its own, so pi by 25 squared by h, so 625 pi h will be equal to 100 pi hk. So k on its own, cancel your pi h's. 625 divided by 100 is 6.25. So quite a tricky one, I think, that last part of that question. The proof of cos 2a being cos squared a sine squared a, I think the easiest way to do this is change the cos 2a to the cos of a plus a, and that's the same as the cos of a plus b, where a and b are obviously just a, and the cos of a plus b in the formula booklet is cos a cos b. So you can see where we're going to get the signs here. So we're going to have cos a in the formula booklet, cos a cos b minus sine a sine b. So they're all a's here, so we're going to get minus sine a sine a, which is going to be cos squared a minus sine squared a. So just practice a few of them and it shouldn't be too much of a problem. Now we're asked to use the formula in the second part, cos 2a is equal to cos 2a is equal to cos squared a minus sine squared a to find the value of cos theta, and we're told that the sine of an angle is 1 over root 5. We had something similar where it was 2 over root 5, so the sine of the angle they're giving us is theta over 2 is 1 over root 5. From the question we saw previously, that would mean that one would have to be 2. So the cos of theta over 2 is equal to 2 over root 5. And the cos of 2a would be the cos of theta. Be equal to the cos of theta. So we fill that into this guy, the cos of theta then becomes cos squared. See, a is half of 2a, so cos squared theta over 2 minus sine squared theta over 2. And we've got the cos of theta over 2 to be 2 over root 5, so 2 over root 5 squared minus the sine of theta over 2 is 1 over root 5. So that's going to give 4 over 5 minus 1 over 5, which is equal to 3 over 5. And finally, for trig identities, is this tan b plus 150 is equal to minus root 3, which we've seen already too. The tan of 60 is root 3. So when is tan not positive? Well, our reference angle is definitely the inverse tan of root 3. It's equal to 60 degrees. So let's see, does this work out if we do our 60 degree in here and our 60 degree in here, because tan is positive in the other two. So this is going to be 300 and 660. This is going to be 120 and 480. So b plus 150 is equal to 120. So I don't think that's going to work for us. b plus 480. No, b plus 150 is 480. So b will be equal to 330. And b plus 150 is equal to 300. B will be equal to 150 in this case, and B plus 150 is equal to 660. B will be equal to 510, which is too high. So I think the two answers for this one are 330 and 150. And if you check in your calculator, the tan of 480 is in fact negative root 3, as is the tan of 300. So that question finalizes your revision, hopefully, for trig identities and functions.